Thank you all for coming. I want to welcome you to the first Red Talk of the fall semester. These are sponsored by the Data Science Initiative, which is part of the Office of Research and Innovation. We do have 2 additional talks that will be happening this fall. So Cynthia Rudin will be, some of you in statistics have seen her, but she will be back giving a broad talk in November. And then we'll also have Steve Koonin from the, he'll be talking about urban analytics. Steve works a lot with all of the instrumentation and data collection that's going on in New York City. And we'll talk some about how analytics support some of those city activities. So for those of you all who are statistics students, the clipboard is moving around. Who's got the clipboard? Yeah, it's in the back, so you can find it. And then if you're a computer science student, someone is here for you to be able to swipe. I'm looking for the person, wave. He might be right outside the door. Fair enough. And so, anyway, so thank you guys for coming. What I'd like to do now is introduce our speaker for this evening, who is Dr. Richard Hendra, and he directs the Center for Data Insights at MDRC. His focus is on the application of data science methods to help improve programs and to better serve populations in need. So his expertise lays in experimental design, data science, and workforce policy. And he's currently leading several national evaluations in policy areas focused on low-income populations, but is also the principal investigator or senior advisor focused on issues around employment, housing, criminal justice, financial inclusion, substance abuse, etc. So our speaker tonight has thought a lot about how data can impact policy, and we're delighted to have him kicking off our series for this fall. So, Dr. Hendra.
Great. Well, thank you for having me. Can you hear me okay? Great. So I have to say, as someone who used SAS for 15 years, it was really a thrill to go to a hall called SAS Hall today. So that was excellent. You know you're in a research triangle when you have a place called SAS Hall. So thanks a lot for having me today. I'm going to talk about MDRC and the work we're doing to try to improve social programs through data science. So how many of you have heard of MDRC or know a little bit about us? Okay, that's good, because I'm going to tell you about MDRC and the kind of work that we do, which is our work tends to be focused on using rigorous methods like randomized controlled trials to help understand the effectiveness of different programs and policies that affect low-income people. So we're a nonprofit, mission-driven, anti-poverty organization, very deliberately focused on building evidence in this area. So we only take studies that are focused on low-income populations. We're very deliberate about that. And we also only try to work on studies that are going to build knowledge instead of just sort of doing scattershot studies here and there where the funding is. We try to be as systematic as one can be in this field. So I'll talk more about who is MDRC, because that'll help anchor like why we're using data science and how we're using data science. And then I'll talk a little bit about, given my audience here at NC State with you're so well known as being so strong in statistics and data science. I do want to talk a little bit about how we're approaching the work, some of the methods, and then hopefully there'll be time for lots of discussion of projects and case studies. So this is more of a sort of practitioner talk to give you a sense of how we're using these techniques in the quote-unquote real world out there, trying to understand the effects of these programs and how we could make them better. So MDRC formed in 1974. We've been around a long time. We're known for these multi-site, multi-state, large-scale field trials. So just think of doing clinical trials for government policy or of nonprofits, that kind of sector. We do tend to use experimental methods, although in recent years we've loosened up and we're using more quasi-experimental methods because not everything can be studied well experimentally, so we use designs like interrupted time series, regression discontinuity designs, propensity scores, and these kinds of, the various flavors of quasi-experimental designs. So in other words, we're in a causal inference business. We're trying to figure out the cause of different government and the effects of different government and program policies on low-income populations. Mostly we work in the US. We've worked in most US states and major cities. We've also done some work in Canada and the United Kingdom. So this slide tries to give you more of a flavor of like what we usually try to do. This is just one policy domain. This is the welfare to work area. And we've been doing studies in the welfare to work area actually even before the 80s, but I'm just starting from the 1980s here. And the idea here is, again, that systematic experimentation. So I have a picture here of Donald Campbell, who's kind of an inspiration for many of us in this field. If you know Donald Campbell, he talked about the experimenting society. And the vision of the experimenting society is a society that tests public policy scientifically in order to understand what works based on evidence and based on rigorous research designs, and discards programs that don't serve populations well and funds programs that do, so that we therefore evolve policy through scientific experimentation. And in this field of welfare to work, if you look at the trajectory, it's not a policy talk, so I'm not going to go through all this, but the idea is that we've learned a lot by trial and error about how to move the needle for outcomes of low-income individuals who are seeking upward mobility, who are in income maintenance programs. So this is what we usually do at MDRC in a variety of different fields. What I just showed you is just one slice of our worker and family portfolio of projects. We have projects across the entire life cycle, so early childhood, K through 12 education, community colleges, right through adulthood. So we do a lot of these, we have these sort of policy verticals because we think it's very important that you understand the substance of an area in order to do good experimentation. But what's new, and what I'm going to talk about today, is those tan boxes. So we have a couple of cross-cutting centers that we've formed because we recognize that there are different disciplines that one can take across domains that are very useful. So one example of this is behavioral science. So we have a center for applied behavioral sciences that uses behavioral economics methods, nudges, low-cost approaches, understands bottlenecks, very focused on human-centered design across domains. The second box is predictive analytics, and that's what I'm going to talk about today. This is the Center for Data Insights, where I work, where we try to take data science methods across all these different policy domains to better leverage data to improve programs. So that's where we sort of fit in. Okay, so why the data science? We do RCTs, we're known for causal inference, large field trials, not troubles. Why did we get into data science? So I want to try to root this in some of our standard work. So I'll show some results from experiments that we did so you can see why data science can become very important and impactful. Okay, so the first situation is data science for program improvement. Now, randomized controlled trials do not always have very positive results. Sometimes we have results that are not statistically significant and we do not move the needle. We learn from that. In this case, we had an example where we did a study of a program called the Perscolis Institute of Technology. They provide technology training for low-income individuals. They're based in the Bronx, New York. And we did a randomized controlled trial. So we randomized to either get into this program, and if you're in the program, you're a part of the orange line there. And there's a control group, just like in a clinical trial, there's a control group. That's the dashed line. They could receive whatever services were ordinarily available in the community. The difference between the orange line and the dashed line is what we call the impact of the program. This program was quite impactful. It increased earnings about 30% above the control group benchmark, something we don't always see. Those are pretty large effects. But the program wanted to do even better. So after the evaluation, we've been working with them on two issues. One is this program, even though it does serve low-income individuals with lots of barriers to employment, does a lot of screening. So for every 10 individuals that apply to this technology training program, one individual gets in. So they want to try to open up their program. So we're using data-informed methods to assess their assessment process to see if we can have more individuals enroll into the program to experience these impacts. The other point is you can have large average impacts like we have here, but lots of drop-off. Just because a program has large average treatment effects does not mean that everyone is benefiting. In this case, we did what we call a funnel analysis. So if you look at the dark portion of these bars here, that was sort of what we call the program pathway. That's what was supposed to happen. So of those that enrolled in this program, only 69% actually started training. A lot of people dropped off even before the training started. And among that group, a smaller group got a credential in IT. So only 54% both started the training and got the credential, and only 40% did the whole program path. And this is a program that increased earnings 30%, but still a lot of people did not receive all the benefits. So one of the use cases of data science is to develop early warning systems so that before people drop out of a program, we could figure out who needs more support, who needs, maybe it's supportive services or some kind of behavioral nudge, maybe it's a different, more enhanced experience, some remediation, but let's try to figure out if there's likely to be risk before someone drops out. So that's a very common use case that I'll talk about tonight. We do a lot of displays like this. This one's stylized, but this is called a Sankey flow, and I'm sure if some of you in data science are aware of these. Basically, we're trying to understand the pathways through programs. There are multiple customer journeys. So we have the best laid plans. We say you're going to go in, you're going to get into orientation, then you're going to go through soft skills. But the reality is, especially with low-income populations, there are a lot of life gets in the way. There's car repairs, there's emergencies, all sorts of situations. So people take multiple paths through these programs. The Sankey flow diagram can help us understand what are the key risk points, where are those tipping points that if we could intervene just before them, we could help people stay in the program. So that's an example of some of the upfront work that we'll typically do. So before we do data science, we like to look at what we call the program funnel to understand what the drop-off points are and where the program is losing people. Another use case is sometimes we don't move the needle, and we want to understand why and how to do better. So this was a study we did, and I'll talk about this more in a bit. The Center for Employment Opportunity, they work with ex-offenders, individuals who have left incarceration, who are getting reintroduced into the community, provide transitional employment quickly after individuals are back in the community, with a lot of peer support and some training, some soft skill instruction. We did an evaluation and found that this program did reduce recidivism back to jail by 22%, which was statistically significant. That was great to see. But they were very disappointed they had no effects on long-run unemployment. The effects were not statistically significant, and they're actually quite close to, the point estimates were quite close to zero. So they wanted us to go in to try to understand, using predictive modeling, where are people dropping out before they reach that employment milestone? So basically, we're working with them to provide new insights about who's most at risk of dropping out in the program before they get placed in a job. And then how can we tailor services to those individuals and do some A/B testing to figure out how to help them get to the goal line. Another reason why we use data science is to get serious about targeting. So unfortunately, public policy often still takes a one-size-fits-all approach. So we see in many evaluations what we call heterogeneous treatment effects, where there's just different subgroups had different experiences. So the private sector for many years has been doing very tailored marketing, very tailored approaches, but in public policy it's still the case that data-informed approaches to segmentation are not commonly used. So what we're trying to do is use approaches like predictive modeling, like clustering, to segment, to help programs understand more who their different bases are so they can tailor services around those needs. This particular evaluation, I'm not going to go into a ton of detail about it, but it was an evaluation we did a few years ago, a few was like 12, 15 years ago actually, among welfare recipients throughout the US. We had a sample of about 30,000 welfare recipients over 16 sites, 10 states, I believe. And what we found is there were really three segments underneath this data set. There was one group of individuals who had not worked in a very long time. They had major barriers to employment. They had issues like substance abuse. They had mental health issues. They had very, very serious barriers to employment that this particular program was not set up to address. So we need to get to a situation where we match the population to the treatment. The other gray box was the other extreme. There were a lot of people who were being served by this program who had been working consistently and quite frankly did not benefit from the sort of light touch coaching and counseling this program was providing. They might have benefited from other interventions like more serious vocational training, more skill training, but this wasn't the intervention that they needed. There was only one group in the middle that was sort of at a tipping point between good and bad employment trajectories that had impact. So that, the basic point there can be made in lots of different evaluations for lots of different situations, but the point here is about targeting. So data science is a very natural approach to targeting, and that's how we're using it at MDRC. When I talk about targeting, people often, the mind goes to who, right? But it's not just who, it's also where, right, and when. So when is a big issue. We have a lot of duration-dependent behavior, right? So for example, I was talking about people who are recently released from prison. The high-risk period for people who are recently released from prison is right after they get out. And then the risk that they'll go back to jail goes down over time. So we call it negative duration dependence. Employment is the same. If you work with populations that are placed in employment, especially for populations that have a history of unstable employment, the highest risk period is right after they're placed. So it's cost beneficial for programs to focus resources, incentives, supports at that high risk period to bridge people to the low risk period. But instead, resources tend to be distributed evenly over time. So data science enables us to get smarter about who, about when, about where, all these issues. So timing is very important. And I would say the sort of overarching issue we see is we work with all sorts of government agencies at every level, or nonprofits, schools, all over those sectors. There's an issue that data is just underutilized. A lot of these places are swimming in data. Even a lot of the nonprofit organizations we work with have Salesforce and ETO and these great MIS systems. They have tons of outcomes, but a lot of data is used simply for compliance, to report back to the funder or to report back to the government agency. And we just think there's so much potential to use data for program improvement more. So that's mostly, if I could say one thing about why we're using data science is like that. We just see it in organization. I mean, we even see it at our organization. So I'm not trying to say that, I think any organization can use data better, but especially in the social sector, there's a lot of underutilization. So I'll talk a little bit about how we're approaching some of the work. So what is the Center for Data Insights trying to do? We're trying to help organizations with what we're calling operational data science. So this is actually quite a switch for us because we're a research organization. So a research organization, the research posture is sort of you get a data set, you do an analysis, you write a report, you try to disseminate it. This is operational in the sense that it's dealing with everyday management issues that administrators have to deal with. These are not typically big policy questions. This is about how do I work with my caseload that's in front of me right now. So it's a different pace. It has to be faster. The technology has to be much more agile than one would use in a program evaluation. The projects are trying to use whatever methods are useful. We're not going in saying we want to just use predictive analytics just because we like predictive analytics or clustering because we like clustering. We try very hard to use whatever technique matches the use case. So we have no problem running averages and simple tables and dashboards if that's what's most impactful for the client. We do have machine learning applications. We're happy to do that too, but it's not sort of a method looking for a problem to solve. It's the problem has to lead in these cases. We're also trying to get organizations to think more broadly about data. So as you all know, data is not just what's in rows and columns. These places have lots of really rich data in case notes, lots of really rich data locked in PDF files that could be liberated and used for analysis. So just having that conversation about natural language processing and how that could improve things is really important. The tendency is just to go straight to the spreadsheet and load it into R and use that. But there's they have a lot of rich data that's underutilized. So we can help agencies, nonprofits, schools with program improvement, improvements in processes, targeting, rapid measurement. So by there I mean the A/B testing. So the randomized controlled trials that I was talking about would often take 3 to 5 years. That's not going to work for management problems, right? For management problems, you need much faster cycles. So it's more similar to like what Capital One would do, or Amazon, just really quick experiments, which means you have to have a pipeline set up, right, to mount those kinds of tests. So it's very different. The technology is very different, as I'll talk about. So comparative evaluation projects, this is a very new way of working. With respect to workflow, data, analysis, tools, the technology is constantly changing, right? So if you're interested in data science, you will never stop learning, and what you knew 2 weeks ago is already old, it seems like. It's a very dynamic field. The data needs to be frequently refreshed. So it's not the old model of send us a file, we'll put a copy on our server and work with it, give you an analysis back in a few months. This is real time, so the data checking has to be set up to handle the range of exceptions that can happen. What happens if they deprecate a field in our MIS system? How are you going to handle that? So it's the premium on understanding IT issues, and I'm a social scientist, not a software engineer, so I often have to work with data engineers on this sort of work, and my team does. We have to know enough to know who to talk to in order to handle all the data engineering. There's a lot of pushing and pulling from systems. So Salesforce, for example, is a common MIS system. In one of our projects, we pull from Salesforce, run predictive models in the Google Cloud platform, and have to push. We're building this pipeline where we push the probabilities that are estimated back to Salesforce. So we have work to do to set up these pipelines in order to keep this stuff close to real time. If it's really going to be useful for operational purposes, it has to be. So very different workflows. You have to work in multiple environments. So my team right now, we're all learning about Docker, if you know what Docker is, because we just can't keep optimizing something for every single client's environment. When we try to push some of this technology back to providers to help them to sustain the work, we need to do so in as error-proof a way possible, so we can't get bogged down in everyone's, if they're working in Windows this or a Linux environment or Mac or whatever. So there's a lot of that piece that people don't always talk about all the data engineering under this stuff, but there is quite a bit to learn in that area. But it's not just about technical work. It's the reason that MDRC is really focused on this is because in our view, data science is really an interdisciplinary field which should draw in as much subject matter expertise as possible. So a good data science team is an integrated team that has a lot of subject matter experts on it. So we do try very hard to pull in our operations staff who understand how to run programs. They might not know how to run a neural network, but they know how to run a program. We work closely with our partners to draw in their subject matter expertise. And we also try to draw in from our evidence base from over the years, the RCT work we've done, to build on that as well. So these are interdisciplinary teams that we're working with. We have implementation researchers, qualitative researchers, and we're trying to work out a model of sort of an end-to-end solution, because data science can't solve every problem either. We have to bring in lots of other disciplines. Like once we identify a high-risk group, what do? The data science will often not tell you what to do. It can help you indicate who's most at risk. So we're trying to help organizations also with a lot of technical assistance. So we're trying to help them to ask the right questions. So I'm not sure how much client work you guys have done, but often when you're first working with an organization, they ask really big questions, like really big questions that are not data answerable. They're beyond the scope of what their data could answer. So there's a lot of upfront discussion and scoping, a lot of technical assistance. There's also in this area, especially in an area of working with low-income populations and human subjects, you have to be very careful to do responsible research. There's a lot of community engagement needed, discussion with frontline staff, discussion with participants in these programs. That's really important that the work is done responsibly. Change management is important. So we're developing a class on how to run a data-informed organization, because we think that's very important to sustain this work. We don't want to just do one-off projects, so we're doing this sort of leadership training. So we know that the administrator of a program is not going to be doing the data science, but they're going to be the person who's really going to drive that work forward. So a lot of it is about trying to help them understand what we're doing so we could pull in their expertise, because they know their populations. If we're working at the government agency or a program, they know their populations better than we do. They know their policies better than we do. So it's a dynamic sort of team sport where we're working together and co-designing this stuff. So in terms of the, I'll talk a little bit about the predictive modeling we're doing. It's trying to take advantage of all available data. We're using methods that I think a lot of you would find pretty standard. The one, if we have a secret sauce, I would say it is to the extent to which we're trying to, in the feature generation process, trying to draw in a lot of subject matter expertise. I think that's, beyond that though, I think a lot of what we're doing is fairly standard as it goes in this field, but I'll talk about how we're approaching the work. We're trying to set this up so that the information has an easy feedback loop to staff. That's why I talked about that data engineering piece. It's not always easy to set that up, those pipelines, in a secure and reliable way. And what we're doing basically with predictive modeling is we're figuring out a probability of a risk. So we're not just doing binary categories like at risk or not at risk. We're doing likelihoods between 0 and 1. And we're doing dynamic work. So someone's probability can change as they work their way through a program, which is very important. Because if you only look at intake, it's all about those incoming characteristics, but someone's probability could change once they work their way through the program, of course. So that's an important aspect of how we're approaching the work. Readiness is really important. Now, I would say, not every organization is ready for machine learning, right? And the organizations that we've worked with so far tend to be higher capacity than average. I think over time, as the software gets better and there's less sort of custom work needed for every step, perhaps that may come down. But you have to make sure that an organization is ready. So this is an organization that is already thinking in terms of risk. They're already thinking in terms of trying to segment their cases. They might not have very advanced approaches to that, but they're thinking about customizing and tailoring their services based on people's risk. So if they're thinking that way in upfront discussions, that's a very good sign. They have the ability to act on the information. There's no sense identifying an at-risk group if you're not going to do anything about it, right? So if there are situations, we have programs that we evaluate that are franchise models, which is to say that model is the same no matter what. And that's not a good candidate for machine learning. If you're not going to tailor anything based on that model, then that's not perhaps the best candidate. Then there's data readiness. So we have had a couple of cases where the data, a client wanted to work on a machine learning application, and the data just weren't ready. There was this tremendous missingness, logic issues in the data. And so the way we respond to that is we provide a memo back, which we call a data audit. We say, here are some things that you want to improve in your system. No data system's perfect, we understand that, but it's just the system's just not ready to support either the sample sizes are too low or there's just tremendous missingness or logic issues in the data. So these are just some readiness issues to be aware of. Okay, so the predictive modeling itself, we have the deputy director of our center, Kristen Porter, has developed a multi-step framework that we use. And one of the aspects I think that's a little bit unique about our framework is how careful we are about the upfront data work. So again, I think it comes from our tradition of working with RCTs and government contracts where the data, you have to essentially almost be perfect in your data work. So there's lots and lots of checking. So we're very careful with data handling. And we don't just rush, of course, to the algorithm. I don't quite subscribe to this idea of auto ML that you could just like feed a data set into an algorithm. It could do everything, including the data work. Maybe that's an old fashioned, but I just don't quite see how you get high quality results if you don't do some upfront data work and data cleaning and exploration. So we do spend time on that. And then of course, machine learning is, you're working with hundreds of predictors typically. We're fairly agnostic about algorithm, so we do use ensembling. You never know in advance which algorithm will be the best. In our field, we're not using anything like deep learning. It wouldn't make sense. We don't have those kinds of sample sizes. We're not doing computer vision or anything like that. Our sample sizes might be 1,000, 10,000, not what you would need to really exploit some of the deep learning approaches. Everything is open source. This is new. It's just a lot, we're in this exciting time when we could actually give code back to organizations that can't afford, a $10,000 license for software, right? So it's really exciting, and a lot of those organizations have students who are trained to use these open source tools. So, so that's, for reproducibility, for sustainability, it's an exciting time. And we'll just have to see as we do more and more of these experiments how sustained the work is. So I think the jury is out on that. That's the goal. The last point I made here is about interpretability and transparency. This is a big issue, of course, all over machine learning, but with these kinds of programs, if you just tell a caseworker someone's at high risk, the next question is going to be, well, why? Well, if I'm going to help that person, I need to know what drove that risk score. So local interpretability is a big issue that, as a field, I think we're making progress on. I know there's Lime and other packages that are out there, but it's sort of, it's like when you get a credit score, they could provide you with some insight about why your credit score is high or low. But if you just pass a caseworker a probability and say, oh, this person's at risk, but don't tell them why, that's not as actionable. So interpretability is big, and transparency. If we have a highly complex random forest model that's almost just as good as a logistic regression that people could interpret, this isn't high frequency trading here. This is, the differences, a very small difference in accuracy is a small price to pay for people understanding what we did. So, transparency is important in this space. So I'm sure you'll have a good understanding of what predictive analytics is, but basically, just to go a little bit more granular here, we're taking data from past outcomes where we could observe the outcome, we could observe if someone finished a program, we could observe if they got a job from past cohorts. We train a model, we assess the performance of the model on out-of-sample metrics because we don't want to step into overfitting. So we use the standard sort of like v-fold validation techniques to make sure that we have out-of-sample performance. And then if a model is sufficiently effective, you deploy it into, you apply it, what we used to call scoring of models, and then people are given likelihoods. Like I said, we will tend to start with very simple models. We have no qualms about starting with regression. I think it's a very good practice. Even means and frequencies are good to start with. And then we work our way up, seeing at each stage, what are we getting from logistic regression? What are the features providing? Often a lot of the lift come from the features rather than the algorithms themselves, with these sample sizes at least. And then we certainly will look at the various different flavors and algorithms like gradient boosting machines and random forests, et cetera. Okay, a lot of organizations, when they do use risk in the social policy space, it's often high, medium, low, or sometimes what they'll have is like the green folder, red folder, yellow folder system. Schools sometimes have that. But having a more flexible definition of risk with probabilities, we could give a much more dynamic sense of risk. So we can collapse that probability. We could look at how risk varies by site for different groups, et cetera. We could look at risk over time. And this gives a lot more texture instead of just a very static high risk designation or medium or low. All right, so in terms of the analytical considerations, I think I've made some of these points already. Number 4, valid evaluation is very critical. So the idea again, I mean, I think the field at this point understands overfitting very well, right? So we know we can't just optimize to the sample, that we're training on. So validation, having the right measures for validation is really important. Number 6, I'd like to highlight that just flagging, data science can help us flag who's at risk, but it's not going to tell us always what to do. So that's why in a lot of these cases, what we want to have is operations and behavioral science people with us on these teams, and the program staff themselves, who often have the best ideas about like what do we do once we identify who's at risk. Number 9, I know you have a talk coming up on bias and algorithms, so I'm not going to, we've done a little bit of work in the criminal justice space, but that, as you, I'm sure know, is an area we have to be extremely careful with. So the data themselves can be the artifact or the result of biased practices, right? So for example, racially biased policing practices can create bias in data that even if you don't have race in the model, that data itself can lead to biased results. So you're gonna have a talk on that subject. We're gonna go into Compass, I realize, but that's something, and that's not only in the criminal justice space. We have to be very careful to have ethical review of these studies in advance. There's a whole literature on this topic, but it's really important to be mindful of those issues. So, we typically will start with a model. We'll start with a baseline model. It's always a good practice to have a good baseline. I'm sure that this is what you know from your training. Start with something simple that you can compare to, a naive model, right? And then can we do better? Can we do better with regard to measures? Can we do better with regard to algorithms? How do we define better? Most of the statistics we use are very conventional out of the confusion matrix. So area under the curve, F1, these kinds of statistics. And yeah, as I'm sure you're learning in your classes, trading sensitivity, specificity can be very domain dependent, and there's consultation with, so the various types of errors have different implications in different contexts. If you're building a credit model, it's one set of concerns. If you're building a model looking at risk of high school dropout, it's another set of concerns. So there's a lot of stakeholder engagement that's important there. So in terms of can we do better, of course we're going to look at different algorithms. It's quite easy to systematically build up algorithms to see how they're performing and use data-driven processes. But we do spend, as I mentioned, a lot of time on measure creation, what we call feature generation, trying to talk up front with experts in the area. If we're in a new domain, what are the key factors? What does the literature say? All that old social science stuff is still relevant. I was trained on just the importance of, when we're going to do a quantitative analysis, the first thing you do is read. It's not, or talk to people. It's not just to jump into a data set. You have to understand the domain, what we understand about it. But then also understanding the data generating process. For example, we know in our kinds of studies, missing data has a lot of signal. And just imputing away missings, you're missing a part of the story. So understanding how the data are generated, whether it be survey data or administrative data, what missingness means, can be very important. And then, but beyond that, we blend this with the usual data-driven approaches for dealing with the, coping with the curse of dimensionality, like principal components and clustering and strategies like that. So it's a blend of subject matter expertise and data-driven approaches. Okay, I said all that. So we're in the real world here, right, with models that could affect people's lives. So instead of just jumping in and just, we're a couple of years into our practice. One thing that we wanted to do is get some validation that our methods were sound. We were using all the methods that we had learned about, that we were trained in. So we decided to join a competition, like one of these Kaggle competitions. You're familiar with like Kaggle? So we joined a competition called the Fragile Families Challenge. The Fragile Families is a very famous panel survey given to cohorts of individuals who are on welfare in the United States. It's one of the more famous anti-poverty data sets. And Princeton University sponsored a data science competition to see who could, which team could best predict certain outcomes in the Fragile Families data that they blinded the competitors to. So we worked on 2 outcomes. One was eviction, because we had done a lot of work in housing. We continue to do a lot of work in housing, and the other was job training. And we actually won, for lack of a better term, not to brag about it, but it's just, I was really impressed. The person who led the work, Kristen Porter, really deserves all the credit for that, but it was real affirmation. And we're against all these engineering teams from all over the world who really understood the technical side probably far better than us. But I think it showed that knowledge of how these data are generated in this domain actually counted for something. So it at least gave us a sense that we're doing okay, right, in terms of our algorithms. But and I think what was really important here actually is a lot of the teams that competed in this competition imputed missing values. They just threw them away as noise in the data, and we took it very seriously from previous work. So Kristen did a great job encoding missingness and features around missingness, and I think that's what put us over the top. Okay, so some example projects. So the first foray we had was a work in education called New Visions for Public Schools. This was to develop early warning systems for risk of dropping out of high school. The basic story here was that New Visions had some algorithms up and running already, but sometimes when you figure out that a student is at risk of dropping out of high school, it's too late to act on it. So what our work, working with New Visions did was to try to develop early warning systems coming from data, and to have early warning systems that were dynamic, because what can happen is there can be very local events, like a student has a run of absences that just over 2 weeks, that's not going to really move the needle on a lot of risk indicators, but we tried to develop a model that could be sensitive to these really local runs like that, like of missing attendance. So we're very happy to be able to kind of move the risk detection earlier, back towards 9th and 10th grade instead of deep into 11th grade when it's very late. The other thing with this study, this was our first A/B test in this space. So we mounted an A/B test where we sent text messages to parents in the A group about their children's attendance. It turned out actually that it was null, that we didn't have any significant impacts. But that's how we learn, right? And it was a good experience just to even set up those pipelines in order to do that A/B test. Another early project was a clustering project. So we got a database of 30 million individuals who had applied for payday loans in the United States over the past 5 years. They're mostly online payday loans. And the policy question here is the demand side of the payday loan market. Who's using payday loans? Why? If we're going to develop better products, we need to understand what's driving usage, because there's certainly a lot of demand for these projects, but what's under that demand? So this was basically a segmentation project. We did k-means clustering, and we found quite a bit of heterogeneity, actually. So there was a sense in the field of like this typical payday loan user who is very low income, rolling over loans, getting into default spirals, and we did see a large segment like that, but there are also a lot of middle to high income individuals using payday loans because of issues with medical debt. And there was a smaller group that actually was kind of one and done. So the idea here was to use clustering to get a sense of demand. We combined that with some conjoint testing, some survey research, and some in-depth interviewing in order to develop better approaches that are sounder and healthier than a payday loan with a 400% APR. And the research we did there was actually cited in the rulemaking that the Consumer Financial Protection Bureau did about payday lending. So that was like a mixed methods clustering study. This is one of our bigger studies now that we have. We're in a, kind of right in the middle. This is, again, with the Center for Employment Opportunity, where we're trying to figure out who's most likely to drop out before they get a job. What I think is really exciting about this study is their interdisciplinary approach. So it's not just about developing predictive models. We have behavioral scientists at the table. We have the site at the table. We have a lot of engagement. We're co-creating this work with them. We're using Salesforce data, so it's MIS data, has lots of demographics, conviction history, program participation. And the goal is to develop real-time updates and rapid updates of predictions so that we could intervene before people drop out. But this is the program that's trying to reduce recidivism back to jail, so it's very high stakes. Then when we identify a high-risk group, the idea is that they could use behavioral nudges, supportive services, incentives, various approaches that will come out of the program and behavioral science in order to keep people in. They have a lot of attrition. This is everyone starting at the beginning there, and then the first drop-off is completing a life skills class, then working in a transitional job, getting ready for getting placed in a job, actually getting placed in a job, working for 180 days. Now we're in the 20s. And then working for a year, we're below 10%, right? So there are major attrition issues in terms of getting to the goal milestone. But that's where we start. That's our baseline, and that's what we're going to try to move the needle on. We did a feasibility stage, and this was basically to see, can we develop a predictive model? Can we use the data? Are the data usable for this purpose? And we were able to develop a model that performed well on common metrics. The area under the curve looked good. The various different statistics in the confusion matrix. And the data were sound. They had 10 years of Salesforce data. They have very good data validation over there. So we developed a machine learning model just for feasibility purposes. And now we're in a pilot stage where we're trying to develop this whole pipeline that I was talking about earlier from Salesforce to Google Cloud Platform, where our predictive modeling code is. It's written in R, and then we'll push it back to the provider. Okay, and then the sustainability phase will be passing all that code back, passing the markdown files back to the provider, and then hopefully over time reducing our role. Our role can never go to zero because issues will come up that they'll need technical support on, but we want to be able to train them so that we're less and less relevant as time goes on, or less needed as time goes on. Now I'm just going to give you a quick overview, a couple of things. I know I'm probably a little low on time. So the Perskolas Institute of Technology, this is the front door. So here what we're doing is a data-driven approach to assess the assessment that they have. So they used what's called the TABE test to figure out who enters their program. And what we want to do is build predictive models to see if we could develop a data-informed approach to assessment that can open their door more. So instead of taking 1 out of every 10 individuals, maybe they could let 2 or 3 out of 10. They want to really increase their enrollment. This is a program that's highly effective and wants to spread its impact. So their goal actually is to increase enrollment. And they've asked us to take a look at their assessment practices to figure out if we could expand the pool of individuals who could benefit from this program. And again, just to give you an overview, another project we have is looking at customer feedback data. And this is after an individual finishes a service, they text in what's called a Net Promoter Score, which is how much would you recommend this service to someone else, to a friend or family. So they have something like 30,000 texts. They have also unstructured natural language data as well. And our task here is to figure out how predictive feedback is, not in a causal sense, of course, but just how predictive is it of outcomes, how representative is it, as a possible first stage in including feedback data in predictive models. So we could, quote unquote, develop predictive models that listen. Because a lot of administrative data is used in predictive models, but feedback data, in our experience, has not been used very often. So the Fund for Shared Insight is a foundation that's focused a lot on listening to participants and trying to include participant voices in nonprofit work. I think for time, I'm going to jump over this, although this is one I would recommend taking a look at because we have some results. I'm just going to give you a very quick sense. Basically, here, third grade reading, there's a test called DIBELS, which is to assess reading proficiency. And schools will be given sort of a basic three-tiered assessment, ready, not ready, sort of in the middle. What we wanted to do was to see if we could work with all the tons and tons of data that actually go into that. There's all these tests and subtests, and I think there was something like 150 data points that no human could keep in their head. So what was very interesting about this use case, which I hadn't thought about, is it's machine learning as a compilation device, just to put all this information into one probability, instead of, and what the team that worked, I didn't work on this one, but what the team that worked on it found is the machine learning-based approach that took advantage of all that available data had a 73 to 78% true positive rate, which was higher, quite a bit higher than the standard assessment being used in that school district. So that was exciting to see and an interesting application. And the last project that I'll talk about is it's called the TANF Data Collaborative. What we're trying to do here is we're building capacity in a TANF system. So this is our website, tanfdata.org. So we're doing a lot of technical assistance and training at state TANF offices. We're doing pilots. We're doing a data science training led by New York University, data integration training led by AISP, which is Actionable Intelligence for Social Policy at the University of Pennsylvania. Like all of our projects, it's all about trying to leverage data in the system to try to help develop better programs. So, so I think we'll make the slides available so you could read through this. I just want to make sure there's a little bit of time for questions. But we have pilots available that we're going to be starting soon. 8 states are going to have pilots to do data-driven projects so that they could free up some staff time to work on this. And then we're developing data-driven training, and we have the Applied Data Analytics course that NYU offers, which has been very effective. Okay. So, the very last thing is we also have an initiative to work from past experiments, looking at our own data holdings. We could learn a lot from previous experiments, so we're trying to see whether we could match to old experiments to learn about the long-term impacts of programs. So I think I'll probably cut it there. I just want to say that we think this is an area of tremendous potential, and I know a lot of data science is happening in the private sector. There's a lot of need to help participants who are in these programs. It's great to work on mission-focused work. It's exciting. It's impactful, and it's a space where there's, while I think we've made some progress, there's always room for more. So I'd encourage you to take a look at working in the social sector. So with that, I'll close and see if there's any questions.
Thanks. So we are taping and streaming. So if you all have questions, let me pass you the microphone.
Just towards the end there, what is TANF? I don't know if you said that, but
TANF
what is that organization?
Cash Welfare, so it's the Temporary Assistance for Needy Families program. So it's part of the safety net program for low-income individuals. So each state has their own TANF program.
I noticed that you were with the groups you're working with, you saw there was a lot of unstructured data that they never used. Have you gone back in any of your studies, because you did the classical way, and then with the data sets they have, and then looked at it again, looking at the unstructured data?
Yeah, we recently did that with some survey data we had. So in the past, we've asked very few open-ended questions because of the amount of coding necessary. So we used to have teams of research assistants for hours coding the open-ended natural language responses. And so we'd ask very few, and it's really a shame because a lot of the richest data in a survey is from open-ended questions. So we recently looked at one of our studies where we asked people, like, sort of, what did you find most impactful and effective about a program? What didn't you like? And we found some good insights about program improvement that would not have shown up in the survey itself. So in that case, what we did is we mined previous verbatim survey responses. And we found that used to be something that would take 2-3 weeks and a lot of budget. So we would not, frankly, do it because it was just too expensive. But now with natural language processing, it's much easier to do. We did find it to be useful. We have not used case note data yet, though. That's what we really want to do next.
So I think that your comment that missing data had a lot of signal was pretty insightful. Is that something where, for a particular field, you talk to kind of experts in that area to figure out what signal might be sent from that? Or is it something where numerically you're looking at kind of correlations or, like the random forest, things like that, to figure out what that signal might be sending?
Yeah, that case came from the fact that we had done a lot of surveys with similar populations. We understood patterns of missingness, so we know what item missingness looks like in those surveys. We know what overall response bias looks like, and we knew that it's not at all missing at random. And so a lot of the guidance that came out for that competition was suggestions about how to impute. We're like, no, we're not going to impute because we're going to be throwing away a lot of signal by doing that.
We'll see whether Christine or I gets there quicker.
So you kind of touched upon this when you were talking about putting models in production with the Salesforce data. So how often do you have to update the model or the life cycle of model in production?
Not our current thinking on that is every quarter at the most, right? Because these are fairly stable processes. For example, the risk of not being employed is something that's, there's some factors like education and various barriers to employment that don't change a lot over time. The economy doesn't change overnight. So refreshing every day seems like overkill. And also what we have to balance is the sort of infrastructure that's in place at a nonprofit organization. So probably, over time, they're not going to be able to refresh at that rate. So we have to, at the most, quarterly is what we're thinking. We're not thinking that we need to update as we go overnight or something like that. So not that frequently. So basically, the idea is we get a model developed that has good validation, and then we're scoring it. We're using that model as it is. But that model is dynamic in the sense that as people work through the program funnel, their probabilities can change. But we're not retraining it every night. It's just, we don't see a need for that yet.
Can you just talk a little bit about what the makeup of your teams are? So how many domain experts are there? How many stats, data science people are there? What their degrees are and that kind of thing? And how you all work together?
Yeah, we, on a typical team, we'll have one person who's usually a PhD level person who has a lot of sort of research design knowledge. We have small teams. We have a data scientist, which is at the analyst level, which is usually master's level. We'll have someone helping with coding who'll be a technical research assistant, which is bachelor's level. And then we'll bring in an operations staff, which is someone who knows typically almost nothing about data or data science, but knows a lot about programs and people and how to do this stuff in the real world. I like to put those people in the lead, actually, on these teams, because they're the ones, they understand enough to be able to communicate it, and if we can't communicate to them, we're not going to be able to communicate it to the site. So we'll typically have an operations staff, and then the behavioral scientists will come in as needed. But at the most, 4 to 5 people on these teams or smaller teams. Our whole department, I mean, we're growing, but right now we have 7 or 8 individuals doing a lot of this work.
You spoke about statistical significance and using that as your cutoff in determining when to make changes within these organizations. And when you consider practical significance alongside that statistical significance, do you find that there seems to be a difference in policy implementation, or does that not come into play?
Yeah, it's a big issue. The field is slow to, this field is still very classical, right, in how we're using statistical significance and p-value and over-interpreting p-values. So I would say that part of the challenge is we're working on continuous programming improvement efforts that might have very small samples. So they're underpowered, but should we just not do it? Is the idea. So we're trying to slowly but surely get the field used to this idea that statistical significance is not the be-all and end-all of everything, because otherwise we're not going to do research, right? So so it's a process, and especially when you're doing A/B testing, sometimes the effects can be quite small. So we're trying to. I think there's a place for more use of Bayesian methods actually in our area, Bayesian shrinkage perhaps to take advantage of when we have pools to draw from to get some more power, but. Statistical significance is still king in public policy. So if that's what did that get to your question? Yeah. Okay, great.
Okay, so we do have a reception set up next door with some cake and refreshments. And so if you have additional questions or would like to chat with the speaker some more, or just want some cake, please join us next door. So let's thank our speaker again.